Now let's look at one more example of an improper integral of the second type, where we have to do some more work in terms of the actual integration technique and also in terms of the limit. We'll see that some problems will involve L'Hopital's rule to help us compute the limit as well, and this will be one of those cases. We'll also see we'll be using integration by parts in this example, and having to use integration by parts and having to use L'Hopital's rule often go together, because with integration by parts you're dealing with a product of things. With L'Hopital's rule, you're using that when you have an indeterminate form, sometimes an indeterminate product form that might show up, and so that's what we're going to see here. So notice that the problem value in this case here is at 0, because my function of e to the 1 over x cubed would not be defined at 0, both because I have this x cubed in the denominator and I also have this 1 over x here in the numerator. So I know that even if I'm not quite sure how to integrate this yet, I need to start by writing my integral as a limit. So this is going to be an integral from -1 to b of e to the 1 over x cubed dx. And we're going to be approaching 0 from the left. Remember, we're always approaching our value from inside the interval. So in this case, that means approaching 0 from the left. So now I want to think about what integration technique that I want to use here. Well, I do have a product. If I look at this as e to the 1 over x times 1 over x cubed, a product of two different kinds of functions. So I want to try integration by parts on this. Okay, so I want to let u, in this case, be 1 over x. I'm actually going to look at this product here as the following. So I have e to the 1 over x squared times 1 over x dx. Okay, and the reason that I want to look at it like this is if this had been x squared in the denominator instead of x cubed, I could have used u substitution. Okay, because if u was equal to this 1 over x, I know that my du would be -1 over x squared. So this part is actually going to be not too bad to integrate with a u substitution, but then I have this extra part. So I'm going to make that extra part my u and have my dv be e to the 1 over x squared dx. Okay, you could have, instead of starting this problem with integration by parts, you could have started this problem with a u substitution and let u be the 1 over x there, and then see how that simplified a little. But we're going to go right into integration by parts. So our du here is -1 over x squared dx. And what's our v? Okay, well, v is going to involve taking the integral here of e to the 1 over x squared. So I'm going to do a little substitution. So w would be 1 over x. Our dw is -1 over x squared dx. So notice this will be e to the w times negative dw, okay, which will make that negative e to the w, or negative e to the 1 over x. Okay, so we have our different pieces, so we can go ahead and write down what this is using our integration by parts formula. So remember, integration by parts says the integral of u dv equals uv minus the integral of v du. So we have our u part, and the rest of this part here became my my dv. So now I'm going to have my integral here from -1 to, whoops, I'll have my formula here, uv, so that'll be -1 over x e to the 1 over x, and that's evaluated from -1 to b. And then I'll have minus my integral of v du, so that'll be my negative e to the 1 over x times -1 over x squared dx from -1 to b. Okay. Okay, so we see we can clean up these signs a little bit, so I have plus a positive here. And notice that what I'm integrating here is e to the 1 over x times 1 over x squared, which is exactly what we already integrated over here when we were finding our v. We had the integral of e to the 1 over x squared. So we don't have to redo the u substitution. We can use what we just found, and we know that this antiderivative here is going to be negative e to the 1 over x. So notice I'm going to have the limit as b goes to 0 from the right, negative 1 over x, e to the 1 over x from negative 1 to b, minus this negative e to the 1 over x from negative 1 to b. Okay, so now we're ready to plug in those bounds, okay, and see what kind of expression we get in terms of b. So just to remind ourselves about the different steps here, we write the integral as a limit first, very first step every time, okay? Then the next couple of steps involved finding the antiderivative, okay? And now I need to make sure that I plug in my bounds in terms of b, which is the particular variable that I've chosen in this case. Okay, I got to be careful not to jump ahead and start taking the limit or plugging in 0. I need to make sure that I get this expression in terms of b and then look at taking my limit. Okay. Because even if you're having trouble taking the limit, if you take each of these individual steps, that earns you a good portion of the credit on a problem, showing you understand each step, and maybe you just got stuck at the very end computing a limit. So let's look at plugging in these values. So I'm going to plug in b here. This is negative 1 over b, e to the 1 over b. Then I'm going to have minus negative 1 over negative 1, e to the 1 over negative 1, or e to the negative 1. Okay. Then I have e to the 1 over b here, minus e to the negative 1. Okay. So let's look at simplifying this as much as we can here. Notice that I have this negative e to the negative 1 and another negative e to the negative 1. So I really have two copies of this e to the negative 1. Notice that e to the negative 1 is also 1 over e. So we could say I have negative 2 over e here. So I have my limit as b goes to 0 from the right. I have this negative 1 over b, e to the 1 over b, plus e to the 1 over b, and then minus 2 over e. Okay, well, the minus 2 over e part, the limit of that will just remain that constant. So we can go ahead and deal with that part. So I have negative 2 over e, and then I'm going to have plus my limit as b goes to 0 from the right of that sum. Okay, so let's look at each of these pieces here. Maybe I can go ahead and take one of those limits already. So what about this e to the 1 over b piece? Well, what's the limit as b goes to 0 from the right of 1 over b? Okay, well, if we think of the graph of 1 over x, then the limit as I approach x from the right, as I approach 0 from the right here, will go up to positive infinity. So this limit as b goes to 0 from the right of 1 over b will be infinity. Okay, so I think about 1 over b going to something, whoops, I think I changed something from the left to the right somewhere along the way here. Yep, I did. So this is where we have to be a little careful. So this is going to make a big difference in terms of what this is later. So I'm going to make sure we copy our work correctly from step to step. Sorry about that. So that's going to change what we're doing over here. Okay, this is from the left and from the left. So I don't want to know what this limit is here from the right. I want to know what the limit is from the left. Okay, well, if I'm approaching 0 from the left here, I'm going off to negative infinity. Okay, so if I have 1 divided by a small negative number, that's going to be negative infinity. then I think about what does that mean for the limit as b goes to 0 from the left of e to the 1 over b. Well, now I have e to some very large negative number. Or I can think of that as 1 over e to a big positive number, so that's going to have to be 0. Okay, you're taking e, raising it to this really large negative number. Thinking about our exponent rules, that's like having 1 over e to a really big positive number, so that will come out to be 0. Okay, so I have 0 for this piece, and then I need to worry about my limit here of negative 1 over b e to the 1 over b. Okay, and this is where L'Hopital's rule is going to come in to this particular problem. So notice that, oops, I did it again. Sorry, this should be a limit from the left. So we know that this 1 over b here, as we approach 0 from the left, is going to negative infinity. So this negative 1 over b here is going to infinity. And e to the 1 over b is going to 0. So remember our different indeterminate forms. This is an indeterminate form of type 0 times infinity. Okay, so the strategy when we had one of those product indeterminate forms was to turn it into a quotient of type infinity over infinity or 0 over 0 so that we could use L'Hopital's rule on it. Okay, so we'll go look at doing that separately here. So where our limit as b goes to 0 from the left of negative 1 over b e to the 1 over b can be written as the limit as b goes to 0 from the left of negative e to the 1 over b as one way of rewriting it. So in this way we have a 0 over 0 type form, so we could apply L'Hopital's rule to that, but it turns out that having that particular fraction will not be as helpful as switching the order. So instead of doing L'Hopital's rule on that, okay, we can also write this as negative 1 over b over e to the negative 1 over b. Okay, so putting the reciprocal of b in the numerator and then making our exponent here negative and putting it in the denominator. So notice that this here is now an infinity over infinity indeterminate form. And so we're going to use L'Hopital's rule on that particular form. So this gives me the limit as b goes to 0 from the left. The derivative of the numerator of negative 1 over b will be 1 over b squared, and then my derivative of e to the negative 1 over b will be e to the negative 1 over b times the derivative of negative 1 over b, which is again 1 over b squared. So notice we get some nice cancellation here. So we're looking at the limit as b goes to 0 from the left. I can move this e to the negative 1 over b back up to the numerator. Okay, and notice that that's a limit we already looked at before. We know that that limit is equal to 0. Okay, so what we have here with this in-between work is that our value of our integral comes out to just negative 2 over e. Okay, so sometimes when you're working with these improper integral problems, you can get a more involved case like this one where you'll have to do maybe some integration by parts, maybe L'Hopital's rule here in order to evaluate your integral. So we can conclude in this case that our integral, which we were asked about, which was the integral from negative 1 to 0 of e to the 1 over x cubed dx, converges. We can also specifically say it converges to negative 2 over e.